The sun was rising on the ancient city of Jerusalem. Israel is the marijuana research capital of the world, and I wanted to meet the man who started it all.
When people call you the grandfather of marijuana research, are you okay with that title?
Well, I'm a grandfather, okay. I have 7 grandchildren.
Raphael Meshulam is a chemist, and he became interested in marijuana in the 1960s.
Morphine had been isolated from opium in the 19th century, early 19th century. Cocaine had been isolated from coca leaves mid-19th century, and here we were, mid-20th century, and yet the chemistry of cannabis was not known. So it looked like an interesting project.
But not an easy one. You see, here, like everywhere else, marijuana was illegal.
So how did you get the marijuana for your work?
We got our material from the police. I just went to the police. I went over and took 5 kilos of hashish. And I didn't have a car at that time. I was in the bus carrying 5 kilos of hashish with people were just saying it's kind of a strange smell. We tested that in a few volunteers, including ourselves.
It might seem like a simple experiment, but the results were revolutionary.
They were the first to isolate THC and CBD decades ago.
2 ingredients in marijuana that might have powerful abilities to treat disease. In Israel today, marijuana is an accepted part of medical care. For pain, for cancer patients, for sleep problems, epilepsy, digestive problems. They're even looking at Parkinson's and Tourette's.
That's a pretty long list.
Well, and the list is expanding. Now, there hasn't been too much research in patients because it's very difficult to do that. It's extremely difficult.
Especially in the United States, which classifies marijuana as a dangerous Schedule I drug. In the US, researchers have to jump through extra hoops to work with it. It's expensive and time-consuming. But the grandfather of this science says he is proof it can be done.
So I can't complain. As a matter of fact, over the last 40, even more years, my work has been supported by the National Institute of Health, the US National Institute of Health.
There have been some great advances here, and I'm proud of that, obviously.
Dr. Boaz Lev is with Israel's Ministry of Health. Here, they have pioneered marijuana research. They were the first to isolate THC and CBD decades ago. And now the country's ministry licensed 10,000 patients to use marijuana medicinally and has approved more than a dozen studies to treat illnesses like PTSD, pain, Crohn's disease, even cancer.
Hopefully, this will prove to be the best medication. I really hope so.
Answers might come from places like this. It's a state-run nursing home outside of Tel Aviv. Residents here are using marijuana for pain, loss of appetite, Parkinson's disease, and dementia. Moshe Root is one of those residents. He was 77 when he smoked his first pipe of marijuana. He's 80 now, and he smokes a couple of times a day. It's to help with the pain and the hand tremors caused by a stroke.
So it's a mixture of tobacco and marijuana.
He even decided to light up during our interview to stop his hands from shaking.
You're saying your hands are steady because of the marijuana?
It also helped ease a deeper pain hidden from sight. You see, Moshe is a Holocaust survivor. When his wife died a couple years ago, he was haunted by nightmares of his childhood, hiding from the Nazis. The marijuana, he says, took him out of the darkness.
You dream. You fly.
When you smoke?
Yeah.
There are 19 other patients here. Scientists at Tel Aviv University are now studying their progress, and they call the results outstanding, including weight gain, improved mood, pain and tremor reduction. But I can tell you as a doctor, it was my next stop that proved the most surprising. This is Israel's largest hospital, Sheba Medical Center.
You put up your medical cannabis.
Amashe is using marijuana to help him with the pain and nausea from chemotherapy.
filling up this balloon. So that's your medicine inside there.
Of course, now take it out, put up the valve.
And he's doing it inside the hospital.
How are you feeling?
I really, first of all, in the muscle, in the leg.
And you're not worried about any potential damage to your body?
Not at all. The opposite, actually. I really believe I can be cancer-free for a long time if I continue, consume cannabis.
Yes, he said cancer-free. Very early studies on mice in Israel, Spain, and the United States are now showing the potential of marijuana to kill cancer cells. It's exciting research, but it is still in its infancy, and it's inconclusive. This program at Sheba is well established, and experts say a teaching tool for using marijuana in other hospitals.
Dozens of major studies have been published in the last few years that indicate that the chemicals in cannabis, in the lab and in animals, have a significant effect on fighting almost all major cancers, including brain, breast, prostate, lung, thyroid, colon, skin, pituitary, melanoma, and leukemia cancers. They do this by promoting the death of cancer cells that have forgotten how to die, as well as a reduction in their crucial blood supply, while leaving healthy cells untouched. But why, you may wonder, would cannabis have any effect on cancer? The answer can be explained in one word: endocannabinoids. Amazing as it sounds, we're all born with a form of cannabis already in our bodies. It's called the endocannabinoid system. The endocannabinoid system, or ECS, influences multiple physiological processes. This intricate system modulates energy intake as well as nutrient transport, metabolism, and storage. A completely natural collection of compounds, endocannabinoids are our body's own form of marijuana and are involved in most of our cells and structures. They control a variety of functions in the nervous system, heart, reproductive, and immune systems. Endocannabinoid messengers help the cells communicate. Typically, they protect our good cells while killing the bad ones, like cancer cells. In all animals, the nervous system is made of the same components, large numbers of nerve cells carrying electrical signals. And wherever the cells meet, these signals are passed to a receptor in the next cell by a chemical messenger called a neurotransmitter. Inside the brain, there are different types of neurotransmitters, including dopamine and serotonin. All animals, from rodents to fish to elephants to humans, have inherited this basic structure. But hundreds of millions of years ago, the sea squirt and other primitive invertebrates evolved an innovation to this system.
What happened was the nervous system acquired a new chemical, if you like, that had a new flavor, a new type of chemical. And it's this chemical that is related in structure, has a similar shape to the chemical that's found in cannabis.
Because of this similarity, these new signals came to be known as cannabinoids. It was inevitable that eventually cannabis would meet its perfect partner: us. Whether you like it or not, each and every one of us is fundamentally wired to respond to cannabis.
Now, receptors are not built in our brain or anywhere in our body, of course, or animal bodies, because there is a plant out there that will produce a compound that acts on them. That just doesn't work that way. Receptors are found in our body because we produce compound that will activate those receptors. So obviously we thought that there should be endogenous those receptors. The fact that there is a plant compound, a tetrahydrocannabinol, a THC, which acts on those receptors, is just a quirk of nature.
Intriguing answers started appearing in the early 90s when researchers pinpointed receptors in the brain and the body that bind with the cannabinoids. Receptors can be described as locks on the surface of a cell, and when the correct key binds with the correct lock or receptor, it opens the door and delivers messages. Sometimes the message is that the body is feeling pain. Other times the message may be that there's an invader and the immune system must attack.
Scientists located two receptors cannabinoid receptors, one called the CB1 receptor, mainly in the brain, and the other is the CB2 receptor, which is mainly in cells of the immune system.
The CB1 receptors are extremely abundant in the brain, but they're also found all over the body in the major organs, the heart, the liver, kidneys, and pancreas. After finding all these locks that accepted the cannabis key, researchers made the next big discovery. The human body makes its own cannabinoids, called endocannabinoids.
We have this whole elaborate system where we have these receptors in our brain and in our immune system, and these circulating chemicals that we produce ourselves that really are very, very similar to the chemicals in the marijuana plant.
The only difference is that the endocannabinoids that we produce are in such small quantities, and they're also rapidly degraded, so that therefore we are not high all the time, or we don't have that feeling of euphoria all the time.
Dr. Prakash Nayagarkatti is a professor of pathology and microbiology at the University of South Carolina. For the last decade, he's been doing research on what's become known as the human endocannabinoid system.
The precise functions of the endocannabinoid system is it's still being understood, actually.
The discovery of the system, however, is already revealing clues that have bolstered the personal stories of relief. The areas of the brain that control nausea and vomiting, chronic pain, and epileptic seizures all have cannabinoid receptors.
What do these things do? Well, in the brain and the nervous system, the cannabinoid system seems to exert kind of a dampening effect. It's kind of an internal, I like to think of it as a neurological shock absorber.
And when they looked in other animals, they found these receptors were present in basically all animal species. So why do dogs and monkeys, for example, need to have cannabinoid receptors?
They must be playing a very critical role in trying to maintain some of the physiological functions.
The whole development of the fact that there are cannabinoid receptors in endocannabinoids has really given drug companies and pharmaceutical investigators a lot of opportunity to try to manipulate the body's own cannabinoid system.
That's because now they can create synthetic drugs that target the receptors instead of taking chemicals from the plant. By avoiding the plant, they get around the controversies and complications of its Schedule I status. A search of the U.S. patent database reveals numerous large pharmaceutical companies have filed recent patents claiming their cannabinoid receptor drug has the potential to treat almost everything: multiple sclerosis, Alzheimer's, Parkinson's, rheumatoid arthritis, Tourette's, epilepsy, heart disease, obesity, various mental illnesses, and the holy grail of medicine, a cancer cure.
We feel that these cannabinoids give us an opportunity to study their functions, and see how we can exploit them, how we can manipulate these cannabinoids and the receptors to find cures for a large number of diseases currently in which there is particularly no cure.
As an immunologist, Dr. Nayagarkatti and his researchers at the University of South Carolina are exploring the impact cannabinoids and the CB2 receptors have on the human immune system. Both U.S. reports on marijuana found the cannabinoids do suppress the immune system, and previously this was seen as a concern. But Dr. Nayagarkatti believes tamping down the immune system could be a good thing.
There are about 80 different autoimmune diseases, and basically autoimmune diseases are triggered by your immune system going haywire, getting hyperactivated and destroying certain cells and certain tissues.
In multiple sclerosis, for example, the immune system suddenly begins attacking the brain and the spinal cord. Rheumatoid arthritis and lupus are similar diseases caused by the chronic inflammation associated with an immune system gone amok.
The cannabinoids dampen down response to bacteria or foreign agents or injury to tissues.
A lot of scientists and researchers are interested in those properties of the cannabinoids, in trying to see how we can suppress the immune response in autoimmune disease conditions.
For Dr. Nayagar-Kadi, the research has gone far beyond treating inflammatory problems. He's narrowing in on the potential of cannabinoids to kill immune cells that have mutated and become cancerous. Once they become cancerous, they no longer die a normal cell death. Instead, they begin growing and spreading uncontrollably.
We were one of the first labs to demonstrate basically that not only the immune cells, the normal immune cells express these cannabinoid receptors called the CB2 receptors, but also that when these immune cells get transformed and they become cancer, to our surprise we found that these cancer cells continue to express these CB2 receptors.
This was an exciting discovery because the CB2 receptor can act like a target for the cannabinoids. Once they bind with the receptor, they can tell the cancer cell to die.
So basically telling the cells basically to commit suicide, and that's what they do. And we demonstrated that that would be the mechanism by which the cannabinoids can kill the cancer, and therefore it can be used effectively as an anti-cancer agent.
Dr. Nayagar-Kadi and his researchers were able to eradicate almost 100% of the cancer in test tubes. But they were skeptical they would see similar results when they moved on to tumors in mice.
To our surprise, we found that almost 25 to 30% of the mice completely rejected the tumor. They were completely cured. And in addition, we found that the remaining mice also, there was a significant reduction in the volume or the size of the tumors as well.
The lab results have been so promising that Dr. Nayagar-Kadi is beginning clinical trials with leukemia patients. There's no doubt in his mind that the cannabinoids, either from the plant or lab created, will play a major role in medicine in the future.
I feel that in the next 5 or 10 years there is going to be exponential growth in cannabinoid research.
It's an area where both the critics and the advocates agree. Scientists are now well on their way to developing medicines based on the cannabinoids.
Come on through, John.
Thank you. So this is it?
This is it, and you can see here one of our growing areas and a fairly wide selection of plants. Come on in and have a look.
Thank you. Gosh, there's loads of it. How many plants have we got here?
There's about 5,000 plants here, and every year we grow about 30,000.
And how much sort of volume of cannabis would this produce a year?
Well, the payload, the botanical raw materials, it's called, about a ton.
Gosh.
To turn it into a saleable pain relief medicine, the cannabis is first dried. Each and every plant is a clone, so that the exact properties are known and consistent.
It's rather like hanging out the washing. Let's go in here now.
Up to you.
Thank you very much. We need to get into this kit, I'm afraid.
Okay. Okay.
Next, it is milled and heated.
So we see the raw material there, botanical raw material.
Right.
Will be put into the mill, and it's ground down to particles of about 1 millimetre.
But at this stage, nothing's wasted.
Nothing
all goes in.
All goes in there, exactly.
The plant material is reduced to a concentrate.
And then it ends up in here, spinning down at 60 degrees, and all the ethanol just evaporates away. To give you an idea of the sort of material it is, you can see it's sort of treacle-like.
Yeah, it's quite sticky, isn't it?
It really is quite sticky, and that makes it quite hard to work with, therefore.
Let's have a look at that. Oh, right. So, oh, gosh.
The final product is a liquid which the patient sprays into their mouth, so removing the need for harmful smoking. Yet, despite this meticulous processing, it's still not widely available. It's not exactly taking its place in the pharmacies across the country. Is that because the effects are quite weak?
I don't think they're not weak at all. I think that cannabis wouldn't have survived over the millennia as a medicinal entity if it had been weak. And cannabis-based medicines aren't weak. It's simply that we're dealing, I think, with a group of patients who, first of all, have tried all the standard medicines and haven't responded before they ever come into the clinical trials with this particular drug. We're dealing with outcome measures which are rather vague, so pain and spasticity are very difficult to quantify in a research situation.
Despite this, so far the only available product is a treatment for pain caused by multiple sclerosis, and this is licensed only in Canada. But there's the possibility of treating many more ailments thanks to an unexpected property of the plant.
If you look in the microscope there, you'll see sort of some glistening golf ball-like structures. And those are the glandular trichomes in the inflorescence of the plant, which contain all the chemicals that we're interested in for making a medicine.
It's not just THC. These trichomes contain CBD, another valuable chemical.
There's quite a lot of CBD in that particular one as well, cannabidiol, which is another cannabinoid, a non-psychoactive cannabinoid, which we think is actually a very important component of the medicine.
So from your point of view, in terms of developing medications, cannabidiol, CBD, what role does that have?
Well, we hope it's going to... I mean, we're fascinated by this stuff, which, you know, has tremendous potential as an anti-inflammatory,
yes,
but also, rather surprisingly, as an antipsychotic.
So, hold on, you're telling me that CBD could be a treatment for psychosis?
Isn't that ironic? With all the sort of tremendous publicity around the link with cannabis smoking and the potential of increasing the risk of psychosis, here we have a component of the plant which itself is antipsychotic.
And we're saying that the same plant...
Within the same plant you've got a chemical which actually has a completely opposite effect and which may therefore be protective to some extent. And so I think it's a level of concern that some of the recreational cannabis that's out there contains no CBD at all. And that is a modern phenomenon. Previously, you know, it was much more usual for people to be smoking some cannabis with some CBD in it at least.
As recreational cannabis plants are grown for higher THC content, so their CBD content falls, simply because the plant isn't able to produce high levels of both.
So your trick as a developer of medication is to, I suppose, change the relative balance of THC and CBD, cannabidiol.
Exactly. Getting that proportion right for different conditions is going to be absolutely key. So we think that for pain and spasticity, a roughly equal balance of THC and CBD is good, because each has their own type of pharmacology, quite separate mechanisms of action, and they interact together in a helpful way, probably along with other plant constituents too. But for other conditions, like perhaps inflammation or psychosis, you wouldn't want probably any THC at all.
Right.
You'd want some of the other plant components, but you'd want the CBD mainly alongside those other components.
Please welcome Dr. Cristina Sanchez, the molecular biologist who discovered the anti-cancer properties of THC.
My name is Cristina Sanchez, and I work at Complutense University in Madrid, Spain. And I have been working for the last decade on the anti-tumor effects of cannabinoids. In the early 1960s, Rafi Meshulam from the Hebrew University in Israel characterized the main compound in marijuana producing the psychoactive effects that we all know. The cannabis plant has been known for millennia. After the discovery of this compound that is called THC, it was pretty obvious that this compound had to be acting on the cells, on our organism, through a mechanism, through a molecular mechanism. And in the 1980s, two specific targets for THC were discovered, something that we call cannabinoid receptors. And after the discovery of the receptor, it was obvious that our body has to synthesize something that binds to these receptors. It was pretty obvious that was something endogenously produced by our own bodies that was acting through these receptors. And these produced cannabinoids were found a few years later, and it's what we call the endocannabinoids, because they are produced endogenously inside our bodies. These compounds, the endocannabinoids, together with the receptors and the enzymes that synthesize, that produce the endocannabinoids and that degrade the endocannabinoids, are what we call the endocannabinoid system. And we now know that the endocannabinoid system regulates a lot of biological function. Appetite, food intake, motor behavior, reproduction, and many, many other functions. And that's why the plant has such a wide therapeutic potential. We started working in this project 15 years ago, and it was basically by chance. We were working with astrocytes at that time, And we decided to change the model and work with astrocytoma cells, the tumoral cells. And we observed that when we treated these cells with cannabinoids, THC, the main psychoactive component of cannabis, it was killing the cells in our petri dishes. We were killing the cells. So we thought that we were facing some potential anti-tumoral responses. And then we decided to analyze these compounds in animal models of breast and brain tumors. The results we have obtained are telling us that cannabinoids may be useful for the treatment of breast cancer. We started to do experiments in animal models of glioblastoma, brain tumors, and we observed that cannabinoids were very potent in reducing tumor growth. Cells can die in different ways, and after cannabinoid treatment, they were dying in the clean way. They were committing suicide, which is something you really want when you have an anti-tumoral drug. One of the advantages of cannabinoids or cannabinoid-based medicines would be that they target specifically tumor cells. They do not have any toxic effect on normal, non-tumoral cells. And this is an advantage with respect of standard chemotherapy that target basically everything. When we started to see these anti-tumor and cell-killing effects on cancer cells, we decided to set aside our metabolic studies and to focus on cancer. I cannot understand why in the States cannabis is under Schedule 1, because it is pretty obvious, not only from our work, but from work from many other researchers, that the plant has a very wide therapeutic potential. We are in contact with doctors in Spain, oncologists, neuro-oncologists, and breast specialists that are willing to test these compounds in human patients. The plant, besides THC, produces cannabidiol. And this compound is very special because it is not psychoactive. It has been demonstrated that it's a very, very potent antioxidant. It protects the brain from stress and from damage, kills cancer cells, and when you combine it with THC, it produces synergistic effects, which means that the effect of THC is potentiated. At this point, we have enough preclinical evidence supporting the idea that cannabinoids may have anti-tumoral properties. We, as researchers, should explore in more depth and be willing to try in many different pathologies.
What is the evidence that marijuana smoking, habitual marijuana smoking, can lead to lung cancer? With respect to the development of lung cancer, we found no evidence of any increased risk of lung cancer occurrence in association with marijuana smoking alone. The marijuana smokers, if anything, had a reduced risk for developing lung cancer. Not a significantly reduced risk, but reduced less than one-fold, so that means reduced. Whereas the tobacco smokers had a markedly increased risk. If those who smoke more than 2 packs a day had a 20-fold increase in the risk. That's 2,000%. Those who smoke from 1 to 2 packs a day had an 8-fold risk. It's 800%. So that contrasts with no risk, no increased risk, or a slightly reduced risk with the marijuana smokers. THC actually has an anti-tumoral effect. And these are studies that were done both in experimental animals and in cell culture systems, and for different kinds of cancer. For lung cancer, breast cancer, thyroid cancer, prostate cancer, gliomas, brain cancer, that the development and growth, or the growth actually of the tumor is suppressed by THC, and metastases are also suppressed. So how can that be? Well, THC impairs protein synthesis, and it's what we call anti-mitogenic or anti-proliferative. You need, so tumor cells don't as readily proliferate in the presence of THC. They're also anti-angiogenic, so they interfere with the growth and development of new blood vessels that are necessary for metastatic spread. And they also are pro-apoptotic. What is apoptosis? Apoptosis is programmed cell death. So when cells age, there is a mechanism whereby the cells die. It's a non-necrotic death to die off the old cells, and we get rid of them before they have an opportunity to develop mutations that would lead to cancer. So enhancing apoptosis diminishes the risk of the cells becoming cancerous. So marijuana turns out, THC rather, turns out to be pro-apoptotic. So those appear to be the mechanisms that might account for these anti-tumoral effects of THC. We decided to do our own case-control study. Funding from the National Institute on Drug Abuse, which is a major funding agency for marijuana-related research. This was the largest study ever conducted on this subject. It was very well designed. We used the Los Angeles Tumor Registry to identify, rapidly ascertain all the cases of lung cancer and head and neck cancer that were diagnosed in the LA County system. And of course, by the time we got to some of them, they'd already died or were too sick, but we got to it over 60% of them who agreed to participate and were able to participate. And we administered this questionnaire, and then we matched them to controls, the same age, socioeconomic status, that lived in the same neighborhood, using an algorithm that USC developed for this purpose, so that we could match, we're comparing apples with apples. And then we administered this detailed questionnaire, the food frequency questions, occupational history, all kinds of things. We also did molecular, we got a buccal smear so we could look at the DNA, we look at the genetics of lung cancer. So what we did was to recruit smokers, heavy smokers of marijuana, at least a joint a day for a week, and it ended up that the average smoker of marijuana whom we recruited smoked 3 joints a day for about 15 years. And we also required that they smoke that much for 5 years. But on the average, they smoked 3 joints for 15 years. So that's about 45 to 50 joint years. A joint year is the number of joints smoked times the number of years smoked. Over the study population was, I think, between 35 and 59. I think 35 was a younger age group. Of course, we thought that they had to be teenagers in their early 20s at the time of at least in the marijuana epidemic, which was in the mid-60s. So prior to that time, very few people used marijuana, but after that time, it just mushroomed up to 1979, which represented actually the apex, the acme of use of marijuana in our society. So that's why we chose those age limits. And so what did we find? For any category of cannabis use, including heavy use we define as more than 10 joint years, but we looked at 20 joint years and 30 joint years. For every category of marijuana use, the ratio was less than 1, meaning reduced risk. It wasn't significantly reduced, but it was reduced. And the confidence intervals were not that wide, around the point estimate. So there was no evidence, and we controlled for all the known or putative factors, for socioeconomic status, concomitant, tobacco smoking, alcohol, etc. At the same time, when we did a similar analysis for the tobacco smokers, there was a huge effect of tobacco.
So I'm a cancer doctor, and every day I see patients with cancer who have nausea from their chemotherapy or their cancer, loss of appetite, pain, depression, insomnia. And my experience over the past 30 years of being an oncologist is that there's one medicine that I could recommend to patients that can take care of all of those problems. Instead of writing 5 different prescription drugs, all of which have side effects and addictive potential, I can tell my cancer patients to try marijuana to take care of any combination of those symptoms.
It's truly amazing the number of conditions that respond favorably to cannabis. The number one condition is pain. Cannabis is useful in relieving people's pain. and it's particularly effective in relieving pain from connective tissue disorders, from arthritis, from fibromyalgia, from systemic lupus, from reflex sympathetic dystrophy, a whole host of conditions that we don't really understand very well. People seem to get good relief from cannabis. People are able to decrease the amount of opiates that they're taking, and in some instances to stop taking opiates entirely for pain control. The first modern research that was done on cannabis was done in 1949 that demonstrated its usefulness in treating epilepsy. I have a number of people who don't have epilepsy when they use cannabis regularly. The founder of modern medicine is a physician named Sir William Osler, who was prominent around the turn of the 19th to the 20th century. He wrote the first textbook of internal medicine, and in that textbook he said that cannabis was the most effective medication for the treatment of migraine headaches. And I certainly have a number of people with migraines who get substantial relief or even prevention of their migraines by consumption of cannabis. Other conditions that commonly respond favorably to marijuana include depression. It helps people with sleep, it helps their appetite. It's also very good in treating GI symptoms, nausea, diarrhea. It's excellent for treating Crohn's disease. We did a little study of people with Crohn's disease and found that many of them were able to stop using steroids and stop using other medications that they had taken for their Crohn's, that they had less diarrhea, they had less abdominal pain. It was a true miracle for them. There's a list here of conditions that was originally developed by Dr. Todd McArea, who was a pioneer in terms of medical marijuana. He actually worked for the National Institute of Mental Health, and his job was to give out grants for doing studies on cannabis. He thought he was there to find out how cannabis was useful to treat medical conditions. NIMH thought he was there to hand out grants to see how dangerous it was. This was a marriage made in hell, and he did not stay with the National Institute of Mental Health for very long. Cannabis is seen as a neuroprotective agent, and we have found that it has provided benefits for people with multiple sclerosis. It certainly treats their neuropathic pain and their muscle spasm, but more importantly, people who were placed on Sativex, the tincture of cannabis, in early studies in Great Britain have remained on it for years and years. And rather than progress, their multiple sclerosis has stayed the same, suggesting that cannabis may not only be effective in reducing the symptoms, but also in slowing the progression of disease. It's helpful in dealing with the anxiety of people that have Alzheimer's disease. It's helpful in dealing with the muscle spasms that are associated with Parkinson's disease. When it comes to psychological illnesses, cannabis is useful in not only treating depression, which I already mentioned, but also bipolar disorder, which is depression and mania. It's useful in treating attention deficit disorder, post-traumatic stress disorder. There was a study done at the Max Planck Institute in Germany a few years back that demonstrated it was useful in reducing fearful memories, so that might suggest why it is useful in alleviating PTSD. This is extremely important at this time when we have so many people who are serving multiple tours in Iraq and Afghanistan. The Pentagon has projected that at least a third of these people, and I think that that is a very conservative estimate, will come back with the symptoms of PTSD. As a matter of fact, in regards to PTSD, both the Israeli government and the Croatian government have given their troops cannabis for treatment of PTSD.
Seth Research Laboratories in California have recently demonstrated that in some tumors, cancer cells are killed by marijuana, while the other healthy cells are left untouched. Cells that stop moving and become still white dots are dead cancer cells. The ability of cannabinoids to kill bad cells is particularly important when we're talking about brain cancer because of the so-called blood-brain barrier. The brain has to be sheltered from outside influences that might hitch a ride on the bloodstream and cause havoc. What is exciting and unique about cannabinoids is that they can pass through the blood-brain barrier because of their slippery, fat-loving nature. Cannabinoids get right into the brain's cancer cells by moving easily through the cell's membranes, which are also composed of lipids. The evidence is piling up in mice-infested labs that the endocannabinoid system, when stimulated by cannabinoids, has an anti-tumor effect and can instruct cancer cells to commit suicide.
This was done by Manuel Guzman's group within the past less than 10 years, and what they showed there was that originally that THC, when injected into a brain tumor in mice and rats, a significant number of those animals the tumor would regress and disappear, so that you actually had survival of rats that would otherwise die. And they examined all the surrounding nerve tissue, and that was all fine, because remember, once again, cannabinoids protect nerves.
Dr. Manuel Guzman is a professor of biochemistry and molecular biology in Madrid, Spain, and is known for his groundbreaking studies on medical cannabis.
Hemos observado que los cannabinoides tienen un efecto inductor de la muerte de las células tumorales, un efecto inhibidor de lo que es el crecimiento, la multiplicación de las células tumorales. Lo que hacen es disminuir el crecimiento de los tumores.
Breast cancer kills more than 41,000 American women every year. Researchers in the San Francisco lab are working to shrink that number, and they're doing it with an unusual weapon, marijuana, or at least a compound from it.
And what we found is that this compound called cannabidiol was particularly effective at inhibiting aggressive breast cancers.
As the primary active constituent of the medicinal plant cannabis, also known as marijuana. Most people are familiar with the euphoric effects of this compound. After entering the bloodstream, this compound becomes available to individual cells in the brain. Delta-9 THC interacts with specific cell surface receptors. It is analogous to a key entering a lock. This triggers a reaction inside the cell. Unexpectedly, this reaction in normal cells is significantly different compared to the reaction in cancer cells. In cancer cells, these reactions lead to cell death. In normal cells, it doesn't. This surprising difference is likely due to two things: a greater number of receptors on the outside of the cancer cells, and a different type of reaction inside the cancer cells as compared to the normal cells. So what we found, the major finding, is that if you combine CBD with THC, you actually enhance the anti-cancer effects of THC. It's been previously reported that THC was effective at inhibiting aggressive brain cancers in vivo, and this what they call preclinical data led to a small clinical trial in Spain. So there's been quite a bit of literature suggesting that if you combine cannabinoids, actually different components of cannabinoids, THC and other similar compounds that similar in structure, that you might be able to enhance the activity of that individual compound. So this is the hypothesis that we worked with. We screened a variety of cannabinoids and against many different types of cancers. And from that screen, we found that this compound called cannabidiol, which happens to be the second most abundant cannabinoid in the plant cannabis, was actually the most active compound when we were testing its ability to inhibit many different types of aggressive cancers. So we combined this compound along with THC in culture dishes of aggressive brain cancer cells, and what we found is we got a synergistic improvement in the ability of THC to not only inhibit the growth of these aggressive brain cancer cells, but also to cause programmed cell death, which is very important because you actually want to kill these tumor cells so they don't have the ability to grow back. And so that's really the major finding. And also within that, we were able to find specific molecular mechanisms that might explain why combining the two compounds makes for a more efficient treatment. And so we're hoping maybe to use that finding to potentially improve treatments, not only in aggressive brain cancer, but perhaps in other aggressive cancers.
So everyone's going to say, great, that means if I have brain cancer or some other cancer, I can just smoke a joint and I'm good, right?
Well, based on the studies in culture and also in vivo, the data suggests that really in order to for the compounds to be active, you have to use quite a high concentration. And you wouldn't be able to reach that concentration by smoking the compound. It really needs to be a direct administration. In fact, in the small clinical trial, they used infusion pumps that were put directly into the brain so they can infuse the compound right directly to the tumor. And that way they were able to get this high concentration to the tumor. So.
There are no deaths from cannabis use anywhere. You can't find one.
In 10,000 years of known use of marijuana, there's never been a single death attributed to marijuana. There's 400,000 deaths in America alone every year that are directly attributed to tobacco.
I've heard that you have to smoke something like 15,000 joints in 20 minutes to get a toxic amount of delta-9 tetrahydrocannabinol. I challenge anybody to do that.
And even in the animal studies where people have loaded the animals up with doses that would be hundreds of times what a human could possibly be exposed to, no, the animals don't die. The LD50 seems to be astronomical.
I mean, you can die from ingesting too much aspirin. You can die from ingesting too much coffee.
The drug warriors who say we have to protect society, save these people, are being just a little bit disingenuous.
Now, why would pharmaceuticals be threatened by a plant? The answer may be as simple as one word: natural. Because a significant amount of research to date has confirmed or suggested that marijuana in its natural state is still the most effective form. Can you imagine a world where you or I wouldn't have to pay for certain medicines?
After dealing with about 10,000 patients over the last 15 years, I would say that over 200 different medical conditions respond favorably to cannabis.
It appears to have benefits that we never ever knew about.
Glaucoma,
epilepsy, muscular dystrophy,
arthritis,
multiple sclerosis,
wasting syndrome,
nausea, chronic pain,
depression, anxiety, hepatitis C, cancer,
chemo,
AIDS patients.
Is there a product out there today that provides as many medical benefits as cannabis?
No.
It remains an unutilized major resource.
The way to riches in the pharmaceutical industry is to have a drug which can be patented.
Cannabis is problematic right from the start because it's a multi-molecule drug.
In 1930, it wasn't possible to patent plants. And that's the reason that pharma never picked up on this, because by synthesizing and owning compounds, that's where the profit motive comes into the pharmaceutical industry.
The patent in the United States lasts for 20 years. Well, you can charge whatever you want at that time, and that's where you make the killing.
There's no money to be made off natural plants. If you can use a natural medicine that you can grow in your own home, which costs pennies to use, you're going to do that.
You need water and dirt. Not only that, you have that plant forever.
Prime motivation behind any drug company is to make money, and as much money as possible.
They're corporations, and corporations, everybody knows that it's like that diffusion of responsibility thing. There's so many people working for corporations that they lose their humanity.
So those are potential customers for these pharmaceutical companies that are not there if they're using a natural plant.
It's unlimited. You grow more, you get more medicine. Pharmaceutical companies don't want you growing your own medicine.
The government supported a small drug company by the name of Unimed to take a synthetic THC, tetrahydrocannabinol, and to put it into capsules to be used as an oral medicine. This became Marinol. This THC in Marinol is exactly the same 21 carbon molecule that's in herbal marijuana. But it's not the same as medical marijuana. It's not a crude mixture of things, and there's no guarantee that you get the same results.
You can make a synthetic delta-9 tetrahydrocannabinol in a test tube. It'll have exactly the same number of atoms and the same arrangement. But how in the test tube can you put the electron spins together, the subatomic quirks and quarks, if you like, of that compound in the same way that a biological enzyme system will put it together? It can't happen.
In the case of a synthetic compound, if it's only an ingredient from the cannabis, they can formulate that as a drug and make a lot more money out of it.
My name is Rick Simpson. I live at 344 Little Forks Road, just outside of Macan, Nova Scotia. I'm here to tell you about the most medicinal plant known to man, hemp. Oils made from the hemp plant are the most medicinally active substances ever found in nature. Up until about 85 years ago, hemp medicines were widely used all over the world. Many drug companies in the 1800s and early 1900s produced hemp medicines for decades. Hemp is a plant, and therefore it cannot be patented. To drug companies, no patent means no money, hence no interest in producing this drug. When you examine bud from the hemp plant, you can see that it is covered in resin. This resin makes the bud appear to be covered in frost. This resin is the medicine. When collected and processed properly, the resulting oil is an effective cure or control for practically any disease known to man, even cancer. We have supplied this oil to dozens of people with cancer. Even people who were diagnosed with terminal cancer by our medical system now have a clean bill of health after treatment with hemp medicine. When working with this medicine, medical miracles are a common occurrence. This oil has brought many people right off their deathbeds. Due to the restrictions put in place by our government against this medicine, we feel that it is our duty to inform the public how they can make their own. In reality, this medicine should be produced on a grand scale in a controlled environment, using the highest quality starting material. Producing hemp medicine in this manner would stabilize the potency of this medication, plus any danger associated with this medicine's production could be eliminated. Sativa strains produce an oil that is a very good antidepressant and tends to energize a person. But most of the hemp oil I produce comes from indica strains. Indica strains tend to relax a person and give them more sleep. Rest and sleep are part of the healing process.
Place the starting material, preferably good bud, in a plastic container. Dampen the bud material in the container with the solvent you are using. Then crush the bud material. After the bud has been crushed, add more solvent until the material is completely covered. I generally use pure naphtha, but 99% isopropyl alcohol also works well as a solvent, as do many other substances. Work and stir the contents to let the THC dissolve into the solvent. This process takes 2 to 3 minutes. Drain the solvent from the starting material and put it through a coffee filter. The solvent now resembles the color of gasoline due to the presence of the hemp oil in the solvent. Make sure the area where you are going to boil the solvent off is very well ventilated. The idea is to carry the fumes away from the boiling solvent to reduce the danger of an explosion or fire. Special care must be taken to avoid red-hot elements or a spark of any kind that could ignite the fumes from the solvent. I have found that an electric rice cooker boils the solvent off very effectively. Bring the solvent oil mix in the rice cooker to a boil. Use a fan to carry the fumes from the solvent away. As the solvent boils off, continue adding more solvent oil mix until it is gone. As the level in the boiling pot comes down for the last time, add 8 to 10 drops of water. Since the boiling point of water is much higher than the boiling point of the solvent used, this water that was added allows the solvent to be released as the oil thickens. As the last of the solvent is being released, it is a good idea to lift the rice cooker and keep the contents in the cooker moving. This helps release any remaining solvent and also protects the oil from too much heat. At no time should the temperature of the oil go over 290 degrees Fahrenheit. Gently pour the oil from the rice cooker into a small metal container. Put this container with the oil into a dehydrator, or put the container on a gentle heating device such as a coffee warmer. It may take a few hours to evaporate the water off the oil. In the end, there should be no bubbling or other activity on the surface of the oil. When the oil is hot, it is quite runny, but as it cools, the oil takes on the consistency of a thick grease. Generally, a pound of good hemp bud will produce about 2 ounces of high-grade oil. Ingesting this amount of oil over a 2 to 3 month period is enough to cure most serious cancers.